Good morning. Good morning. My name is Danilo, and I'm technical evangelist in Amazon Web Services. And this is the first of two dive deep sessions before lunch. My session will focus more on the developer experience using serverless technologies. And then Adrian, who is hiding in the back, will lead the other one. We will talk more about architectural patterns and best practices. So I'm really passionate about serverless. I wrote a book, as Jan mentioned before. It's AWS Lambda in Action from Manning that has been translated to Chinese and Korean. And I also have Manning create an ebook that is a free ebook. It's Agile Development for Serverless Platforms that contains content from my book and other books that gives you an idea of what a web API is, how you can build a serverless application, and how you can apply agile methodologies to serverless development. So it's a nice overview and a quick intro to the technology. So let's get into the focus. So what's a serverless application? So you can read thousands of articles on Medium and these platforms discussing what's serverless and what's not. The idea is that you have services that are fully managed so that you don't need to think about how they're built, and functions that are, again, fully managed, and they work together. So usually the services act as event source, as triggers of functions. On AWS, that's Lambda functions. And here in Lambda function, you can put your business logic. And you can use your traditional development skills. There's no big change required. You can use the lots of different languages. As Ian said, we also recently added an updated version of for C# and also the Go language. But you can use Java, Python, Node.js. If you want on Java, you can actually use any language that runs on the JVM 8. So there's people running Clojure or Scala on Lambda functions. And these Lambda functions they have internet access. If you want, you can give private access to your local resources. You can provide connectivity back to your data center. So you can really see the database that can be inside your on-premise data center, or everything that is online or available on the internet. And customers, they love this approach. We've seen lots of different use cases, from mobile apps and backends with Airbnb to Coca-Cola. I will talk briefly about the use case in the step functions, because they use this for vending machines. In media, that's very popular. So we have companies like Condé Nast. They created a photographic platform under the Vogue brand where photographers could share their pictures. We have Expedia, that's a very high throughput backend, and it needs to manage all those transactions that they have. The Internet of Things with iRobot. And it's interesting, it's most of those customers, they share what they built. And if you go, for example, on YouTube and you search for reInvent 2017, you can find most of those customers on stage sharing what they were doing, their best practices, what were the advantages that they got from this new approach. And those are the most common use cases that we've seen. So web applications, so you can very easily build a web application that can scale from 1 view per month to thousands of views per second. Backends, so mobile and IoT backends, so your backend API basically, and that's very easy to see because you can basically map an API invocation to a function. Data processing, this is a very, very interesting and high throughput use case. Normally, processing streams of data in real time has never been easy. Now, if you use tools like Kinesis together with Lambda functions, you can really easily process information at speed and with very low latency. We even have a reference architecture for doing MapReduce with Lambda. That means that you can put your files on Amazon S3, that's an object storage, and then you can use Lambda functions to decompose in smaller chunks, process these smaller chunks in parallel, and then reduce the final result and put it together. Chatbots and Amazon Alexa, that's a very interesting use case. We have lots of tools with those tools that probably are being now described in the AI track. Tools like Lex, for example, you can build a chat box that can be used on the web, on the mobile, via voice or text. And another interesting use case, and this has often been also one of the way new customers adopt the platform, is IT automation. So all those old school scripts that one needs to run to automate the infrastructure. So of course, when you run AWS, everything is an API, so you can really manage all of your infrastructure using a script. And it's better not to keep those like maybe a PowerShell or a Bash shell script, but you can put those into a Lambda function. You can very easily schedule Lambda functions so that they're executed at a certain time of the day or of the month. And if you go behind simple scripts, you can use step functions. We will see that later, just after lunch, to build more powerful coordination for scripts that need to access different resources. And using AWS Lambda, as I said, is easy. You just bring your own code. You can also bring your own libraries. So Lambda is actually a binary environment. So if you bring your own binary with the function, we will execute the binary. We give you information in the documentation of what's the binary environment that we use. It's an Amazon Linux. And for example, I have a Lambda function using OpenCV. It's an open computer vision library. It's built in C++, but has bindings to Python or Node.js. So you can bring the compile shared library, and then it just runs in the Lambda functions. Before Go was officially available as a language, most people was just building a Go static binary. That's very easy to do with Go, and then using a wrapper functions in Python or Node.js to execute the Go binary when there was an invocation. As Ian already said, you can grow the memory from 128 megabytes, that's the minimum, up to now 3 gigabytes. And when you add memory, you add more CPU power, more I/O capacity, more networking capacity. Be careful, when you reach 1.8 gigabytes, you start to see the second core. So up to 1.8 gigabytes, your function will just go faster. After 1.8, you need to have 2 threads to use all the computing capacity that you have. Otherwise, you will still use 1 core, and you will not see improvement on the CPU usage. And I think languages like Go, for example, are very good to do this kind of parallel use cases. We will see in detail, but there are 2 kinds of invocation of Lambda functions: synchronous and asynchronous. Depending on how you use them. And these 2 frameworks are the way we approach an integration with other AWS services. And it's also interesting to see how flexible the authorization is. Sometimes when I talk with developers used to work locally on the laptop, they see all the necessary authentication and authorization that Lambda brings as a complication, but actually that means that you already are with 1 foot on the production environment, because you already have to think about what your Lambda function can do, what resources can have access to when you're still in the development phase. Security is built in, you can't delegate that at a later time. To improve the authoring of functions, we integrated the new Cloud9 editor in the console, and we will see how that can help development experience. And we also have plugins for other common development environments. So if you use C#, you have a plugin for Visual Studio. For Java, we have a plugin for Eclipse. We improved monitor and logging. We will see how in the console you can very easily, from the monitoring, select the section of time that you are interested to, and then get the related logs. The programming model is actually very basic, in the sense that you have access, as I said, to all the resources inside the container where the Lambda function is running. So you can use multiple process, multiple threads if you want. You have access to a /tmp. It's a temporary file system that's created with a container. So every concurrent execution of your function has their own /tmp. That means that you can't assume that if you write something there, you will find it again, but you can easily use this /tmp as a cache. So for example, if you need to download something at the beginning of your function, if it's already there, you know that that's been downloaded by a previous execution of the function. So that's a fair use of /tmp. Of course, any temporary work is okay, but you can't assume that another execution will see what you left with the previous one, because we can use a different container. And the programming model that Lambda brings you to use is stateless. So the Lambda functions by themselves, they don't have a state. They need to write the state somewhere. Some see this as a limitation. I see this as a good programming approach, especially if you want to scale. So it's just a mindset. Maybe it needs to change compared to what you used to do. Lots of web developers, they they think that every customer has their own cookie, and then they bind every customer and write maybe all the data inside the cookie. Here you are in a more stateless environment. You have to think what's the best way to manage the state of the data that you're processing. Price is very fine-grained, and this is what customers love. So you pay by the hundreds of milliseconds of execution time of the functions. You also pay for the invocations, but usually that's a lower price. There's no minimum. So as I said, you can create a Lambda function. There's no cost even in the storage of the function. And then you pay only for the invocation. And we also have a huge free tier that it's available for all customers. So this doesn't expire after the first year. It's always active. And you have the first 1 million requests and 400,000 gigabyte seconds of compute time every month for free. So 1 million of requests is easy to understand. It's just 1 million of invocations. 400,000 gigabyte seconds means that if you use 1 gigabyte of memory for your function, then you have 400,000 seconds of execution time. If you use half the memory, you have twice the time, because the price is linear with the memory. So if you use 128 megabyte, that's the minimum amount of memory that you can use, you have 3.2 million of seconds, because 8 times more time available. But actually, time and cost are quite strange with Lambda. So first of all, if you execute things sequentially or in parallel, you pay the same. So usually it's always better to go in parallel if possible. And then if you increase the memory, you increase the cost, but you also get more CPU. So maybe your function is going faster. So this is an extreme example with a CPU-bound function that was just doing some maths. So it was computing all the prime numbers that are less than 1 million. And then we call this function 1,000 times. So lots of computation here. And if you use 128 megabyte, it was taking almost 12 seconds to do that. If you use more memory, you get more CPU, and then you get the same results in 1.5 second. But if we look at the pricing, since the pricing was increasing linearly with the memory, but the time was also decreasing linearly, the price is almost the same. So if you have a compute-intensive Lambda function, increasing the memory may not affect the price, or maybe depending on how the compute part of your function is relative to the other parts of your function, it can just increase the price a little bit. So my suggestion is maybe try and play a little bit with different memory sizes, because you can get benefit without having a huge increase in price. As I said, Lambda functions are integrated with lots of AWS services, especially with triggers, so other services that can trigger a Lambda function when something happens in the AWS cloud. So data stores, this is a very common use case, especially Amazon S3, our object storage. You can easily set up a workflow where if a user from a mobile app is uploading a picture straight to S3, and you have the security to do that from the mobile app, then this triggers a Lambda function that can do some processing, can check that the function is okay, can be shared, can extract information using artificial intelligence services like recognition, can create thumbnails, and so on. We also have endpoints. These are very useful to help integrate the Lambda function with other applications. So the Amazon API Gateway, it gives you a web interface, a web API interface to the Lambda functions. AWS IoT allows you to connect your functions with the IoT world. I already mentioned iRobot, so the Roomba device that maybe some of you have there in the new model in the 900 lines. They use Lambda functions when they connect to the cloud. And it's also integrated with development and management tools. So this is more the internal use case. So for example, if you commit your code on AWS Code Commit, you can trigger a Lambda function that can, for example, complete the CI/CD pipeline, or can do just some basic syntax checks on your code, or run some tests, some automated tests. You can create alarms that trigger Lambda function. You can have CloudTrail, as we said, to monitor how your functions have been executed, and if something happens, you can trigger a Lambda function. And also we have some more bus event messages services, so both on the email side, but also on the notification. So Amazon SNS is a notification service. It's a sort of publish and subscribe service, and it's very common to use this as a bus to exchange information and trigger Lambda functions if necessary. You can also trigger Lambda functions with cron events. This is implemented using CloudWatch events in the console, and then you can, as I said, schedule your typical housekeeping activities of an AWS account, like taking backups, cleaning unused space, and so on. This is the execution model for Lambda. So as I said, we have the synchronous and asynchronous approach. So the synchronous approach is what, for example, the API gateway is using. So you invoke the Lambda function, you wait for the termination of the function so you can get the result and send the result back to the client. We also have asynchronous events, for example, S3 or SNS as asynchronous. So if you upload a file on S3, this triggers a Lambda function, then S3 is not concerned anymore in what's happening. The Lambda function can execute for up to 5 minutes and then can eventually write the result somewhere else. For stream-based applications, we have a slightly different approach. So it looks like the asynchronous one, but it's slightly different. So if you have a Kinesis stream or a DynamoDB stream is similar to a Kinesis stream, but contains all the events that happen on the database. So if someone is updating the database, we write all this information in a stream of data. So with Kinesis, we have this stream of information. This is very common in use case like IoT, for example, or if you want to understand what your customers are doing. For example, your application can publish information on a Kinesis stream, and then you can process this information in almost real time. So one of the big values of DynamoDB streams and Kinesis streams is that they preserve order. And this is very important. So usually you have a key, maybe your customer ID or your physical device ID in the case of IoT, and then we will preserve the order of the messages that are sent by a specific customer or device. This is very important because both for database updates and for events happening in the real world, the order is important. You can't commute the order. If I subscribe to your service and then I disable the subscription, it's different than if I try to disable and then I enable the subscription. You want to preserve the order when you process this information. So in this case, what we do, we basically have a model. I think Adrian will go deeper into it, that it works like the asynchronous one, but it's preserving the order of the messages. With pure asynchronous events, you don't have order. So if I upload 1,000 files all at once on S3, I have 1,000 functions fired, but there's no guaranteeing which is the order of these 1,000 functions. Here, we preserve the order. The permission model, I think it's very interesting, and even if it's a little bit different from what we used to do as developers when we work locally, I think it's very important because it brings you to think how a distributed application should work. So you have two sets of permissions. One is the execution policy, so what the function can do. So it can read from S3, it can write on S3, it can have access to a specific resource. And then who can actually invoke the function? So maybe S3, if as a trigger, can invoke the function. The Amazon API gateway, if I call an API, can invoke a function. So the fact that you have these two sets of different permissions allows you to really play with security in a different way, because you can give some permission to the Lambda function that are only executed by the Lambda function logic, and then someone external, even to your AWS account, can trigger this Lambda function and act on the local resources. So think of this carefully. It's really a powerful model. And using these features, customers are doing, as I said, incredible things. This is FINRA. They are a financial authority in the US. They monitor public stock markets and all the activities to find for frauds or strange usage and strange transactions. So they use Lambda, and they monitor they do 500 billion validations on the data every day. And they are super happy about the fact that it auto-scales. So the stock market, if you see the volumes of the stock market, is not linear. There are days where there are 30, 100 times more transactions than other days. Previously, for them, it was hard to catch up. Now, this is managed by Lambda, and they increased the default limit of 1,000 execution, concurrent execution, of course. This is Thomson Reuters, and this is an interesting use case. They're using an architecture similar to one I was mentioning before with Kinesis. So they have lots of products that their customers use. Usually they provide information, videos and this kind of information to customers, and they want to know how their customers are using their platform. So they send up to 400,000 messages per second they receive from all their customers about what their customers are doing. So they in their backend they can process this information and understand with analytics how their customers are using their platform and what they can do to improve their platforms. And again, they don't need to do any change here. So again, maybe they release an updated product, they get lots of more messages. They don't need to change anything because they can process all the messages very easily. So the API gateway is an important building block for serverless development because it gives your functions a web interface. Normally, if you see this graph, previously the Amazon CloudFront, our content delivery network, was part of the service. Now you can opt out, so you can have edge optimized or regional optimized endpoints. So that means that the API can be inside your AWS region, so very easy to reach network-wide from other invocation inside your region. Or if you want to have internet users, you can have an edge optimized deployment that is using automatically Amazon CloudFront, our content delivery network. We have more than 100 edge locations across the world, also in Stockholm, and these entry points will then use a network that we manage to reach the region you deploy the API gateway. The API gateway will look into the API, can optionally do authentication and authorization, and then can call a Lambda function, or optionally can also call an HTTPS endpoint on EC2, or any private or public endpoint. Can even invoke other services like step functions, and it's also writing everything that it's doing as on CloudWatch, so that you can have a log and monitoring of how your APIs have been used. So the API gateway can be the entry point. Most use cases use just Lambda in the API gateway, but it's broader than that. And the API gateway can provide a clean interface between your application that it's exposed using the API that you build with the API gateway, and the consumer of the API can be a client application or other microservices. And you know, when you use serverless technology, you basically go into microservices. You have small components that you should keep also smaller. I don't like too big functions. So having clean interface is really mandatory. Otherwise, microservices become a mess. So you need to understand each service, which is the interface, who is consuming this interface is not a concern of the microservice. The important part of the developer of the microservice is defining a standard interface. The API gateway is also protecting your API from DDoS attacks. You can throttle access to your API, so you can scale as much as you want, or you can set up limits. It can manage authentication and authorization. It's integrated with services like Cognito. So Cognito user pools, it's a very interesting feature. We can do a complete management of your users from the validation to the authorization, and it's integrated with the API gateway. And then you can also use this if you want to give access to your consumer of your API using API keys. You can create different tiers like gold tier, silver tier, bronze tier, and then you can throttle, meter, and monetize your API, giving different access depending on the tier, for example, in terms of throughput. You can have also a free tier that is very low throughput access to your APIs. So when we created the API gateway, we gave complete freedom on the way the API is mapped to the backend invocation, for example, to the Lambda invocation. And we used velocity templates from the Apache Velocity project as a syntax to take the input payload from the HTTP request. Then you can parse this HTTP request as you want, and then create the template, the output that is sent to the Lambda function. What we realized over time is that all customers were doing and redoing the same mapping again and again. So we introduced more than 1 year ago. Now the Lambda proxy integration is a default integration that you can enable with easily in the console, and it's the default now if you use Lambda. This is a standard mapping of how an HTTP request arrives from the API gateway is mapped to the Lambda function. So this is the input that the Lambda function will get. It will get the path, the HTTP method. This is a get, a post, the query string parameters, the path parameters, all the information, the body, of course. If it's a binary body, we will encode it using base 64, and we will tell you through this flag that is encoded. So now the Lambda function will receive this in the input event, And then the Lambda function, to give a response back to the API gateway, has to use this syntax. So a status code, it's the HTTP status code, 200 OK, 404 it's a miss, and so on. You can optionally customize the headers, for example, set the content type, pass a body, and then eventually, if you want, you can flag this body as binary, and then you have to pass the body as base 64 encoded, and then we will do the decoding when we send the content back to the client. So if you use this standard syntax, it's super easy to create a web API, and we will do that with the API gateway and Lambda. If you're interested into a new approach with APIs, so we've seen lots of interest in GraphQL. GraphQL is a different protocol that started inside Facebook, but now it's started to be widely adopted. And GraphQL allows you to create more complex schemas. So while with the standard web API, especially if you adhere to the REST model, you need to do lots of invocation if you have a complex data set. Here you can create complex queries, complex mutations. That's how you update the data. We also manage real-time subscriptions. So the possibility that you can say, OK, I want to subscribe to this data, of this customer. If something is changed, send me a notification in real time. We do that using WebSockets. And this is a more advanced use case. We have a new service that we just announced at re:Invent. It's called AppSync. It's in preview, so you can ask if you want to be included in the preview. And it's basically the possibility to map GraphQL queries and mutations to Lambda functions or direct updates to DynamoDB, updates or reads, or updates on reads from Elasticsearch. So basically, you have these three output for now, and it's a different way to build serverless applications. It's very interesting. You can even use just DynamoDB and build a very powerful web front end for most common applications, and then you can extend using Lambda functions. So let's see some of the features live. So we have, as I said, we have now the Cloud9 editor in the Lambda console. We have a graph dependency model of what the function is using. We have test events inside the Lambda functions, and we have the new monitoring view that has been improved a lot. So let's see something live. So this is the Lambda, the AWS console. So in the compute section, there is Lambda. And here, let's start by creating a new function. And we can author from scratch, use one of the standard blueprints, or you can use the serverless application repository that Ian's introduced previously. So here you find big application already there, easy to use, and they're open source, so you can have access to the source code. Let's create a function from scratch. Let's call it, so this is usually the example that I do at the beginning. So usually you start with an hello world, but since we have a function, I do a hello by name. So you pass the name and you get hello. And let's call it greetings, greetings on demand. I'm using Node.js, but there are other languages available, as I said, with the new Go and others. Node and Python are the only ones that you can use interactively in the console. For the other ones, you need an IDE like Cloud9 or your favorite IDE to connect and send the packaged function. So I'm starting with Node.js. As I said, you need to create a role. You can't create a Lambda function that doesn't have any permission. For example, you need permission to log. If you don't give permission to log, the Lambda function will not be able to write any log, and then it's very difficult to be sure that your Lambda function is working. So I create a new role. I don't need to use any template because I just need basic role. And I use the same role name as the function name so that I can easily find it back and extend it or delete it if I need it. Now I'm creating the function. And of course, this is the time where the demo is slower than. So the network was working good. So I usually keep like a live ping, so the ping is okay. Okay, the function is okay. This is the dependency graph that I was mentioning. So this function doesn't have any trigger. It would be here. And it has access to these resources. So the basic permission that we gave is to write to CloudWatch logs so that you have logs of what the function is doing. And here I have the integration with Code9. I can even zoom to full screen if I want. And then I can write my code here. So since I'm very bad in live coding, I already created a basic function to to start with. And this is the basic prototype of a function. So I have an export in JavaScript of an anonymous function. So the name of this function will be handler. A console log, like print in Python, will automatically become a log that we write on CloudWatch logs. I log the input event. I create a name variable. If there is a name in the event, so the event is a JSON, but in this case is already transformed into a JavaScript object. If there is a name in the event, use this name. Otherwise, use word as default, and then build hello plus the name, so hello word or hello Danilo, for example. Write the greetings and send back the greetings. So for JavaScript, the callback is the standard callback syntax of JavaScript. So the first parameter is the error. Null means no error. It's a correct termination, and then the return value is the second parameter. For Python, it's easier. You just return the value and eventually raise an exception. So this is the code. I can now, and as you see here, I have the index.handler is saying that I'm using handler as the function, because you can have hundreds of functions in your code. Only one will be the one that is invoked by Lambda. So you have to give the function name here. So this syntax is index is the name of the file without the extension. And we see here in that index.js is the name of the file that is created by the console automatically. And then the function name inside the code. So if you have multiple files and multiple functions, file name without extension dot function name will give you the function that Lambda will try to invoke. So if we go down, we see more of the settings. So we have environmental variables. So you can pass environmental variables to your function. We'll use it shortly. You can tag your functions for pricing, for example, or for automation. You can give a description. This is normally useful. I'm not doing that because it's a quick demo. You can give more or less memory. So 128 megabytes is enough to say hello world. The timeout is the maximum limit of the execution of the function. We have currently a maximum time. 3 seconds is enough to say hello world, but I can increase this up to 5 minutes. I think it's good for different perspectives. So if you make a mistake and you trigger a Lambda function that is always running, you need a timeout. Otherwise, you need to kill the function, or you can have like a background process running in the AWS cloud forever, and you still will receive the cost of the Lambda function forever. So it doesn't look very nice, I think. Here you can give access to your private networking if you want. So by default, the function have internet visibility, but you can give visibility to your local VPC and local subnets. In that case, the Lambda function, every concurrent execution of the Lambda function will use an IP address from your subnets. So be careful, you need subnets with lots of IP address, otherwise you can run out of IP address to give to multiple executions. The DL is the dead letter queue. It means if you have a synchronous invocation, like from S3, and you have an error, it's very difficult to trace. So the idea is we can set a dead letter queue after, I think, 3 executions. If the Lambda function is still in error, we will send the input event that is causing the error to this dead letter queue that can be an SQS or SNS queue, and then you can manually or automatically understand what's happening with those events. You can enable, and we will do that later, X-ray tracing, so that you can trace your function. Here you can limit the concurrency of your function. So I currently have 1000 as a global limit in my account, but you can increase that. But you can give a smaller amount to your function. So you can say my function is using 100 concurrent execution. That's removed by my global limit. And now this function can't scale up to 1000. That was shared across all the functions in the region, but only to 100. As Ian already mentioned, this is very useful if you have a bottleneck in the backend, like my Lambda function are using a database and I don't want to have more than 100 concurrent connection to my database. And it's also useful for the VPC. So if you know that you have 100 IP address in your subnets, maybe you don't want to have more than 100 concurrent execution, otherwise your subnets will run out of IP address. So that's another use case where you want to limit that. I'm not limiting now. So let's save. And when I clicked save, this function now has been created and replicated across all the data centers that are in the availability zones. So I'm using Ireland, so I have 3 availability zones. So now this function is running in 3 different data centers in 3 different availability zones. And they all can auto-scale, so it's very robust. Now I can test the function. And this is the integration with the test events. So now I can create my own test events. And if you want, you can create the test events before of the function and use TDD, so test-driven development, and it would work the same. You can start from a template, like if you know that your event is coming from S3. I don't expect you to know the full syntax of the S3 event. It is quite complex. So you can just select here S3. That is probably, I will never, okay, S3 delete, for example, and we write a sample event that you can customize. So in my case, I don't want to do that. I want to start from, okay, let's just delete this. And let's call it with name, and I pass my name. So it's a JSON object, so I pass a name, and my name is Danilo. So this is a sample event that contains a name, and I can use to test my function. So now with name is selected, I can test it, successful, and I get as output, wonder of the wonders, hello Danilo. So the question is, there is an API to automate the test creation. So for now, this has been included in the console, but it's not a Lambda API. So you can do that in the console. We are integrated this in the plugins that we have for the IDE, and this is also being integrated with Cloud9. So if you use a normal IDE, you have that. If you use command lines, then probably you better use a standard tools that it's already there. But it's a good question. Maybe we can dive deeper afterwards. Let's the idea of this presentation is to start basically with the Lambda console and then move to more advanced use cases. So that's the idea of, I want to build something small, I just use the console. Then there are other tools that I can plug in if I want to grow in complexity. So hello Danilo, everything works. Maybe I want to test another event, like I can create a new event, and we can call this without name, and then I send just an empty JavaScript, an empty JSON object, so that doesn't contain a name. And I can test without name, and I get hello world as expected because it's the default. Once you created the event, they're always there. So now it's very easily when you run and you develop to just retest without name and test with name. So it's very easy to do and to build that in a developer experience using just the console. So let's do something a little bit more complex, and let's let's customize the way I greet. So I always say hello. Now what I do, at the beginning, I have some code before of my function. And this is an important concept. So when you create a Lambda function, the code that is before of the function is executed only once when we created the container, once per container. So we can create multiple containers, but not for every function invocation. So if you have some initialization code, or you need to download something or do some pre-work, this is where you put something. Even if you need to connect to a database that has a connection like MySQL, for example, you do the connection here, and then you can reuse the connection for multiple invocations. If we need to scale and we create multiple containers, we will re-execute this code again, but only for every container that we create. So much less than all the function invocation. In this case, I'm just looking if there is in the environment, the standard OS environment. So this is the JavaScript syntax, but for every language you can look in the environment. If there is a salutation, I use that. Otherwise, I use hello by default. And then I log it. And then when I build the greet, now I use the new salutation. So I can now save again. I can test with a name, and we can see that I get again hello Danilo. But now I want to customize my salutation, and every Lambda function in the configuration can add environmental variable that you may use for more important use cases, like the database password or something that a database user that you need to connect to. So I write here a salutation. Let's say good morning. And since we expect people to use this for sensitive information, we have an helper here, I'm not going through, that is automatically using KMS, our key management service, to encrypt the content of this environmental variable, so that the content in the console will not be unclear, will be encrypted, and the value will be decrypted inside the function before of the execution. So this is the right approach for any secret that you need to manage through the environmental variables. So let's save again. I now test my function again, and I get, of course, good morning, Danilo. So now we know how to use environmental variables to customize my Lambda function. This is useful, especially to have a single function that goes through different environments, maybe test and production, because it's very good practice that you don't change the source code, you only send the difference in the environments through customization via the environment. So for now we have this Lambda function that is really alone in the cloud, nobody's invoking it, not very useful. So let's create an API. So I go back to function and I create a new function that I call greetings API. I use the same, so let's create a new role from templates. I don't need any permission. Oops. And I use the same function name for this new API. And if we go here in the Visual Studio, I have a prototype of that. And basically, the function is exactly the same as the one before, but now I'm using this syntax that I introduced here to map the input of the API gateway into the event and then the output. Specifically, I expect the name to be a query string parameter, so something that is passed in the get as a parameter, and then I have to send the response back using that syntax. So let's, so we are still, let me just reload. So the network is always functions being created. So this happens, I noticed that if I don't give focus to the editor when I create it, it doesn't like that. So you need to leave the focus on the browser when you create the function. Okay, so this is the new code. It's very similar to the one before, but now I look into the event query string parameter to see if there is a name. And also I can see optionally an HTTP status. And then I build a response code that is the status that I get, or 200 is the default, and the response body will be hello and my name built in a JSON syntax. So the only difference here is that I'm using this syntax for input and output. So I expect JSON in input and JSON in output with that syntax. I say JSON, but when you take the event in JavaScript, it's already been transformed into a Java object, in a JavaScript object. So I can now test this, but I can test it with the event as before. So I need to create a new event, and now I need the syntax of the API gateway. So let's say API gateway, and here, for example, I can go into the query string parameters and say name Danilo, and now I have my custom event that I can call with name again. Maybe I can add API to distinguish it, and I can test, and I can see test, and I can see that now I get a payload with hello Danilo. But now I can also add the integration with the API gateway. So here I can select the API gateway, and then I can say I want to use the API gateway. I want to create this API. You can optionally customize the API name, a stage. You can have test, production stage, or different production stage for your API gateway. And then the security. Normally your API will be probably secured in some way. Now I'm just create an open access API because I just want to do a quick test. Now I save, and now we have the integration. And if I open here, I have the URL, and I can click, and I should get hello world. Okay, I was too fast. This is the raw data that I get. So it's a very basic API. It's highly available, multi-data center, automatically scalable, and I pay only for what I use. So it's a very basic API, but it gives you an idea of how you can start building that. So let's say that I want to add some logging to this API, but I want to do something smart. Maybe I want to log differently if I'm using debug in the test environment than in the production environment. So I have this very small recommendation that I can give to you. That is, so I update the code. So I select the function. And basically I created this, no, this is not the one that I wanted to. Yeah, it's this one. No, it's this one. Okay. So this is, no, this is not. Oops. I think I overwrote this function during one of the tests. So no worries, I should be on GitHub. In fact, all my functions are on GitHub, and they're here as first serverless functions. And let's see if I also committed the wrong function to GitHub, so I have to enter into the history of GitHub. But the basic idea here was just to add, the idea is that you can create a debug environmental variables that has the debug level, the log level, so it can be low priority, it can be informational, warning, I want to receive all the errors. And then you can, instead of running console.log or print in Python, you can just have a function that checks the log level from the environmental variable, and depending on the value of the log level in the environmental variable, can decide to log this error or not, because you give a log level to any log that you do. So something that you already do probably in your application, is very easy to add to a Lambda function. So that's something that I usually recommend doing. And you can even do it a little bit further. So what I did, but it has been overwritten, is that I also added a do if function. So you can have some code that is executed only if the log level of your application is high. And you can use this for something like assertions. For example, you can execute some code that does some validation if you're in a debug environment, and then this code will not be executed in production because you don't need it. And that's the basic example. So final things that I want to tell you is this. So I mentioned multiple times for this demo is that 5 minutes is the limit for a Lambda function, but sometimes you need to go further. So this is one approach to do that. So I have a function that basically is getting an event that has an item list. Can you see all the code, or is it too small at the back? It's small. So let's zoom a little bit. I think it's better. So basically I take the event and I expect the event to have an item list, and then I start processing this list of things to do. And maybe this list of things to do can't be accomplished in 5 minutes. Maybe it takes 1 hour to do all these things. So what can I do? I have a process list that will take the first item from the list and remove it from the list. I process this item. So this is process item is actually the code that you need to write. Maybe it's processing a picture or extracting some information from data files. And then if the list is empty, so when I finish, there is the callback. So I process this item. If the list is empty, okay, I finished. If the list is not empty, Lambda is passing me the context of the function that is telling me what's happening in the environment where the function is executed. And one of the methods of the context is telling me how much milliseconds are left before my function is being terminated by the timeout. So if the remaining time that I left is greater than some threshold that I know is sufficient to process another element, then I continue and I process another element. I'm using recursion here, but you can avoid if you want. If there is no time left, so I know that it's less than 10 seconds, it's too risky, what I do, I can invoke myself as a function. So I'm not running the code. So I'm invoking the same Lambda function by itself asynchronously. So I use the asynchronous invocation. That means that I pass the remaining list of items to do. So I start with 100 things to do. I process 30. Now the 70 items left, I pass it to myself. I trigger the same function asynchronously. The first function will terminate within the timeout. And the second function will start with now 5 minutes again, and we'll start processing from this list. So this is a very basic example, but it can give you an idea. If you want to build something more robust, you can also use step functions, and we will see that in the next sections after lunch. So this was the first quick demo, and I'm very late, so now I will speed up a little bit. but I think I thought it was interesting. So there's a few codes that you can use to automate your test in the console. But if you go beyond a single function, you need to have some way to structure your code and describe what you're building. So that's why you can use CloudFormation. But CloudFormation actually was designed before serverless, so it's a little bit verbose. So that's why we designed SAM. So SAM is the serverless application model, is an extension of CloudFormation that has been designed to make it easy to describe your serverless architecture with the functions and the events. And then it can also be extended to support anything that CloudFormation currently supports. And it's an open specification because we want to help the market reuse what we already built. So this is an example of a SAM template. So basically here you can create a serverless function. And then you can pass the event here. So you see that is an API that is linked to a certain path. This is actually the default Lambda integration that we just saw. This is the S3 code where the code of my function is. And to tell the CloudFormation that this is a serverless a SAM template, we need to add that transform line at the beginning. That's the only difference. This will create all the resources that CloudFormation needs to build to set up this environment. And the output template would be this. So if you don't use SAM or you want to use CloudFormation directly, it's lots of stuff. When you have this in your code, you can use this couple of command line tools that you can easily integrate in your CI/CD pipeline that will package the code and deploy the code. So the package will take the template, will take your source code and upload it to S3 with a random name so that you can always reuse the same prefix. And then it will write an output template that will be identical to the input, but will have the link to the S3 bucket. And then you can pass this to the deploy that will create the stack. It's very easy. You need to give capabilities to the CloudFormation because you're creating roles and IAM resources. And let's say you want to build something like this. It starts to be complex, so that's why I created this tool. So this is a personal project that I put on GitHub. It's called Serverless by Design that you can use to design and get the SAM template. So just a quick overview. So this is, again, a GitHub project that I hope I didn't overwrite. And here you can just design. So what I can do, I can go on edit, add a node, and I can add an API gateway. And this is my API. Then I can add a Lambda function. And this is my backend that is executing the logic of my API. And this API maybe needs to read and write from an S3 bucket. So this is my bucket. And maybe needs also to read and write from a DynamoDB table. So I write DynamoDB table. This is my table. And then I can add edges. So this is a network model. And each edge is connecting a resource with the others. So I have an API integration with Lambda that then can read and write from S3 and read and write from DynamoDB. And then maybe I want to process what's happening if the S3 is changed. So I can add another Lambda function that is my bucket processor. And I can add another node that is a Lambda function that is my table processor. So it's processing all the changes in my database. And I can just link the bucket with the Lambda function and the DynamoDB table to the Lambda function. For now, I support Node.js and Python to create empty function, and I can export SAM, or if you want, also the serverless framework. This has been added by a colleague. And then I can say, this is my prototype app. I can click build, and now I have it's downloading the archive. And here I have, for example, the template that has been created for this function, the database table. There's lots of assumptions that then you can edit, like the throughput of the DynamoDB table, and the starting code for all the functions that you can use to start writing your code. So, and then you can pass this to code deploy and code CloudFormation the package and CloudFormation deploy for deployment. So last thing that I want to tell you is testing. So testing local. So that's why we created an environment that can help you replicate the Lambda runtime. And we can also help you build these input events that you need to run locally to test, for example, a trigger from S3. And we introduced SemLocal that actually was mostly completely written by Paul Maddox, that is in the other section. And it's using Docker, so it can run on Linux, but using Docker for Windows or Docker for Mac can run on other platforms. It can help you emulate Lambda functions and also generate events. So you can do things like this, like generate an S3 event for this bucket and this key, and then you have the input event that you can test. It supports live debugging with Cloud9, and you can also you can install it very easily with npm. So when you install it, you have this syntax here. Basically, you have validation of package. You can deploy and package similar to what you did before. And then this is the three main commands. You can start an API. So it's a full web server that emulates the API gateway with the triggering of your APIs. Or you can invoke a single Lambda function locally. Or you can generate an event. And it's integrated with Cloud9. I don't have the time, so I will not do the demo for that part now. Maybe I can do it later. So the idea is, OK, now I have everything in my repository. You can build a full continuous integration, continuous deployment pipeline, where you have your source, including the SAM template on GitHub, on code commit, or you can just upload a tarball on Amazon S3. This can trigger a build where you can use your own tool like Jenkins, or you can use our tool, Code Build. You can automate tests using third-party tools, or Code Build can run automated tests, and then can use you can deploy using CloudFormation. And this is all coordinated by Code Pipeline, and this is all set up for you by CodeStar. So if you use CodeStar and you create a project, you have everything set up. And just so the last thing that I want to mention is the alias deployment. So using Lambda functions, now you can have traffic shifting, so that you can have two versions live at the same time. We already mentioned that before, and you can put that into your SEM template. So this is a standard SEM template that is creating just a function. And if you want to add automatic, you can. It's really bad, the colors now. But I don't know if you can read it because the colors are really bad on this screen. You have a global section. Globals means that these properties are applied to all the functions. And then you say auto-publish alias live. And then you can choose a strategy. That in this case, I'm using canary 10%, 10 minutes. So I do a canary deployment for 10% of my users. And then after 10 minutes, I roll this to all my customer. And then you can define alarms and pre- and post-validation function that can check that this canary deployment works. I'm sorry the colors are really bad, but the idea is that you have alarms here and pre- and post-traffic functions that can validate that everything is working. And if something fails, you have the automatic rollback. This is as coordinated by, this is coordinated by code deploy, and then you can visualize and have the logo, what's happening if there is a rollback or not. So I am not doing this demo, and I just want to tell you, if you want to have more view of other developer tools that are available, this is a very interesting link that we have. And there's lots of open source frameworks and third-party frameworks that can help you develop on serverless. Maybe they are closer to your development style, like the serverless framework, Chalice or Zappa for Python developers, Sparta for Go developers. And we have also frameworks for Java and Express.js that can help you take standard application and migrate to serverless very easily. And with this, thank you.